Today our problem, burst balloons. You are given n balloons. Each balloon painted with a number. You need to burst them. If you burst, you get this amount of coins. Now this is 300, so that is screaming like, I think you can fit this. You have like 300 times 10 to 6, that's 3 times 10 to 8, so that should fit into int. And this really is shouting that this is n cubed dp, right? So I remember similar problems, but let's see. This is clearly n cubed, but I wonder what the states are. Because let's say I have like let's try to solve it for a subarray, but now what if we have answer for this subarray and we want answer for that subarray? Good question. Great question. So if you pop this, right, I solve for here and I solve for here, but how do I combine those answers? Different approach. How many subarrays will contain 3? Or how many times we burst it? Well, we can burst each element just once. Okay, let's see. So at some point, right, so this 5 has to eat all elements in front, and only then it's counted. Only then. So as you can see, 8 is counted in all of these, but we don't know in which order to pop all this. So what we want to do is, and we have to do the same for right side. Okay, so that tells us how many ways can we pop these balloons and how many ways can we pop these balloons, and then for this subarray, well, okay, we can pop here, pop this guy, and pop all these guys. So how many ways can we do that? Not really, because answer for this is number of times we're gonna pop this guy. Hard to think about, to be honest. Okay, well, 8 is counted how many times? Well, it's however many times you're gonna destroy element here, right? And how many times you're gonna destroy element here? Well, I don't know. Let's say we have this, and now, okay, how many times is this guy gonna get counted? Well, that depends on how many times we pop this position and how many times this is gonna get. I feel like this is gonna be 5 lines long. I have that feeling, but whatever. Let's see, we can have this many subarrays, and then let's try pop all. Well, how many times, for example, this element gets counted? Well, I think this might be above my pay grade, bro. I was looking at the problem. It has 62% acceptance rate. And I was like, yeah, that must be a nice problem. Hell nah, bro. Hell nah. This requires n-cube-db. There is not even a hint. If there would at least be one hint, like what is the state of the DP or anything. But no. I mean, okay, let's start with brute force, I guess. So how would the brute force, how would the brute force work? Let's see. Well, we can start with 1, right? And then, so there is some element that will be burst last. then there will be some other element that will be burst next. This is the index we are on, and that's it, I guess. And then let's see, and we start with solve 0, and what we can do. This is base case, so what we can do is we can pick these elements. So we have some, let's call it current, right? And then what we do, well, 4j in range n, and now picked is, let's call it like that. So this is what elements are picked, and now if not picked j, then here is what we can do. If j and picked aj, and now if we picked the previous one, ans times equals picked aj minus 1, and if j plus 1 is n, and picked j plus 1, ans times equals j plus 1, and then let's see. Okay, and then ans is max ans, and current plus this, and then picked j false, and then we return ans. Maybe this works. So I guess we don't need this. Great. What is that, bro? $66. I know what's up. Picked. And then I need like next previous or something, so this picked is just a helper. Okay, so that works, but this will TLE. So we got some brute force. We go backwards. Now, are we solving any problem? I mean, technically we could do this in log time, but I have no clue, like absolutely zero clue on how to do this. Okay, that's fair. Maximize some value. Okay. I mean, okay. In hard level problems. Let's try top down first. Okay. Fair enough, but you still did not say anything. Okay. Whatever, I guess I can do that, but so let's say we just try to eliminate these guys. So max ans. So we just return maximum of, and we take AI plus 1 if I 0 else times 1 else AI minus 1 times 1 if I ln A minus 1 else AI plus 1, and then we add solve A except I plus AI plus 1. Interesting. Nice one-liner. But I should not be returning a list, bro. Max of this. Let's print A. Oh, you can't hash a list. Ew. Okay, whatever. Yeah, fair, okay. Okay, I didn't want to do that, but okay. This is kind of stupid idea to have this without seeing it, but whatever. So this is our pseudocode. Okay. I mean, yeah, we realize that. Okay. Let's dig deeper. Decrease number of spend. Okay. But you still don't know which are bursts, so exactly. Oh, but you can pretend one is here actually. Exactly. Okay. What? You do this. Gain remaining. What the hell? All the time, and then how to keep the last burst balloon. What will we gain if we burst free? I mean, okay, but what the hell? What the hell? how do I just guess this that it's not, then it's not the problem. Okay, whatever. EP IJ and then we take like gain is equal to nums left, nums I minus 1 times nums I plus 1, and we get burst plus dp left I plus dp I plus 1 right, return ans like that. That's weird. Like this. Almost. That is weird. I think I have the same thing. I just you go from left to right, you burst the balloons, and then you take burst plus this. Let's copy their code, why not? So if I is over j, great, then we go to j plus 1, here we have k minus 1. Wait a minute. Find the last burst. What the hell? What? I I didn't even notice that. How is that possible? What the hell? Like this is a whole bunch of useless shit until you get here, and the entire point is think backwards. Just mark Numzai as the last burst balloon among left to right. What does that even mean? If we keep Nums alive, easy, just mark Numzai as the last balloon burst. Well, I mean, it burst free, and then what? This bursts it for, and Magnum's ice is the last balloon amongst them. What do we do? instead of bursting the balloon. Well, if I eliminate this is my range, and if this one is gonna be last, damn, that is crazy. Ain't no way, bro. I'm sick of all this today. I spent 8 hours reasoning about approximation problems and I'm sick to my head. Tomorrow I will do it for 5 more hours and hopefully for not a single more minute in my life. I don't know. Dynamic programming, intuition. Let's burst a subarray. Find best score achieved by bursting a subarray. We try bursting each balloon and solving for left and right subarrays created by the boost. Problem with this is that in the left subarray we do not know which element is when trying to burst the last element. We do not know how many next elements to its right are burst. Can we fix this? We think of the instead of going over balloons, we burst first, we go over balloons, we burst last if a certain last and pretend all balloons are there. This way we know what the elements to the right are and what is the cost of the balloon being popped last. Well, it's num_i times it's what is the gain of bursting the balloon last. Well, we just multiply its number with the number of balloons just outside of this array. O of n cubed, since there are O n squared subarrays and we do O n work for each of them. Time complexity O n squared, since there are O of n squared states subarrays. Sorry for this shit video, but it took me 40 minutes and I still don't understand why this works, and I have zero patience anymore. Goodbye.